Hello, dear students. How are you all? I hope you are all good and studying very hard. Today, we will solve another problem from book Irodo, chapter Kinematics. The question number is 1.14. So, without wasting any more time, let's read this question, comprehend the question first, imagine the situation, and let's apply the concept, whatever is required here. Okay. So, what is given? A train of length 350 meter starts moving rectilinearly with constant acceleration of okay, this is written as 3.0 into 3.0 into 10 to the power minus 2 meter per second. T is equal to at t is equal to 30 second after the starts. Okay, t is equal to 30 second after the start, the locomotive headlight is switched on. Headlight means जो आगे होती है ना लाइट उसको बोलते हैं हेडलाइट. So headlight is switched on. That is termed as event 1. Okay, and t is equal to 60 second after that event, the tail signal light is on. जो पीछे वाली लाइट होती है उसकी बात कर रहे हैं, switched on. Find the distance between these two events. This question is really good question, and you will be surprised because in this question you have to analyze the magnitude of numbers also. Whatever the values are coming, you must analyze the situation using those values, and then you will be able to answer this question. How and what velocity relative to earth must a certain frame k move? I will come to this part later, but let's find the distance between these two events. Let me explain you the problem. I will use both Hindi and English as required. Okay, students. So suppose initially this is train, and train is really long, 350-meter long. So this is train. Now this is 350-meter long. Now look at the acceleration. Acceleration is very small. Acceleration is very small. You can see that 3 into 10 to the power minus 2, just that. Okay, fine. So t is equal to 0. At t is equal to 0, this train has started moving with acceleration. We know that acceleration, they represent acceleration as omega, and I denote acceleration as a, which we normally use to denote acceleration. So acceleration is given as 3 meter per second square, 3 into 10 to the power minus 2 meter per second square. Now they are saying 60 second after they start. 60 second is very less for considerable displacement with this acceleration, because क्योंकि acceleration बहुत ज़्यादा कम है ना यहाँ पे, तो 60 सेकेंड में बहुत ही कम डिस्टेंस आगे चलेगा ये. मैं बोल सकता हूँ, let me draw the situation. So this is the situation after 30 second, and they are saying that at 30 second or 30 second after the start, headlights are switched on. Headlights means this. So let me draw like this. So headlight is switched on. This is event 1. Let me mark this as 1. Now now they are saying that 60 seconds after that event, means 60 seconds after this event, the tail lights are on. So let me draw the diagram for this train after 60 seconds of this event. So suppose this is the position after 60 second, position of the train after 60 second, and they are saying that at this instant tail lights are switched on. And I can definitely say that the train has not even crossed its own length, or let me say the train has not even having displacement equal to its length, because look at the numbers, 3 into 10 to the power minus 10 minus 2. So in with this acceleration in 60 second or 90 second, because no, this is 90 second, dear student, this is 90 second, because they are saying 60 second after this event, event 1, and this is considered as event 2. Now headlight is switched on here, so this is event 2, and they are asking the distance between these 2 points. They are asking the distance between these 2 points. This is the question. So what I will do, suppose in t is equal to 0 to t is equal to 30 second, they must have traveled some distance. Let me uh, write it as s1, and in first 90 second they must be traveling some distance as s2, and obviously we can write s1 is equal to half into a into 30 square, right? I think this is very easy because initial velocity is 0. Train has started with the rest with initial velocity 0. S2, how much distance will it travel in 60 seconds? So I will say half into that acceleration. I will put the values later, value of a, and 30 plus 90, 30 plus 60, that is 90 second. In 90 second, the train must have displaced this much value in meter. If I put acceleration as this value, 3 into 10 to the power minus 2. Okay. Now they want to know how much is this. Let me write it as x. So I think you can guess this distance is L, or let me say, mm, how much will be this? Now this is whole L, and this distance is s2 minus s1. Can I say this is s2 minus s1? From here to here it is s2, and from here to here it is s1. So this is s2 minus s1, and we know that from this end to this end the total length of the train is L. So if I subtract s2 minus s1 from L, I will get x. So the distance they are asking is actually L minus s2 minus s1. And now I think we can solve easily. Let me put values. We know the diagram also. We just need to put values. Let me make more space. So L is 350 minus s2 minus s1. So half into acceleration. Now let's put the value 3 into 10 to the power minus 2 into s2 minus s1, that is 90 minus 90 square, uh, 90 square minus 30 square, and this is 350 minus 3 by 2 into, now this is 10 to the power minus 2, and this is, I will get 100 from here, 10 to the power 2, so this will be cancelled. Now 27 minus 9, and this will be 18. Yes, just, oh sorry, 27 is 81. This is 81. This is just a calculation. So 81 minus 9, 72. Now 72 divided by 36, 36 into 3, 108. So this is 350 minus 108, and see what we are getting. So 350 minus 100, that is 250, and 250 plus 8, so this is 258. Oh sorry, यहाँ पे मैंने एक गलती कर दी है, that is we have to subtract 8 more, so 250 minus 8, that means 242 meter, or we can say 2.242 kilometer. So this is the answer. So we have now calculated the answer. Okay, now second part, let's come to second part. I was saying that without analyzing the value of this number, without comparing this number, we won't be able to solve this second part. How and at what velocity v relative to earth must a certain reference frame k move for the two event to occur in same point? Okay, firstly, as we can see, the train has not even displaced the length equal to its own length, right? 350 is its own length, so it has not even completed the distance equal to its own length. So that means I can clearly say that its tail, or let me say its tail will not cross this point. Its, for tail to cross its own length, it must the tail must go in this direction, right? Go beyond this point. I will say this thing in Hindi means ये कि अगर ट्रेन को कम से कम 350 से ज्यादा, या ये कहें कि अगर खुद की लेंथ को भी क्रॉस करना है तो कम से कम 350 से ज्यादा तो ट्रेवल करना पड़ेगा, राइट? बट वी आर सीइंग कि ये जो पॉइंट है, जो डिस्टेंस है, ये खुद 242 मीटर पीछे रह गया है भाई, राइट? तो इसका मतलब ये हुआ, we can say that if we say there is a reference frame in which we want to solve this problem, and we want both this event to occur at same place, we would want that reference frame to travel in this direction, and reference frame that reference frame should start from this point at t is equal to 30, right? So with respect to that frame, suppose event has happened at this point only, and by the time second event happened, this frame should also move to the position of second frame also, like this. So this must be its initial position, and that must be at t is equal to 30 second, and by the time second event occur, that is t is equal to at t is equal to 90 seconds, second event has occurred. So this reference frame must reach at this position also. Actually, you must understand that this whole train is running on same straight line only. Now we know that when first event occur at t is equal to 30 second, the reference frame started running in opposite direction. So with respect to this reference frame, I will say that at t is equal to 30, both this frame and the event 1, both are at same place. Now if for the reference frame the final event must also happen at same place, so I think, or we will say that this reference frame should move to the position of 2, that is this is the position of second event, position 2, by the time this happens. That means at t is equal to 90 second, this reference frame must be at this position. So at this position also, this reference frame will say, yes, second event has also occurred at my place only, first event has also occurred in my place only. So what is the distance traveled by this frame? This is 30. So in 60 seconds, this distance must be v into 60, v into 60 second, and this v into 60 second must be equal to 242 meter, and I think we have solved it. And what we are getting, v is equal to around 4.033 meter per second. I have used calculator just to see, but obviously you don't have that option, so you can do like neglect this 2, and you will see 6 4 ja 24. You will easily get the answer. Sorry, it will be, if I will say this is 40. Yes, it will be 4 meter per second. So I hope students you have understood the problem, and okay, if you have not subscribed the channel, do subscribe, and don't forget to press the bell icon so that you get the notification of all the questions of this series, Erodo series. And soon I am going to start a video series for JEE advanced question, last 10 year JEE advanced question of the physics papers. So I will solve all the question. Then I'm thinking of starting a NEET series also, in which I will try to solve all the good questions from the modules, mainly from the different coaching institute. I will select a variety of number of questions in which the students generally face problems, and I will make a series, and I think there will be around 1,000 questions in the series. In J Advance also, I think we will get around 200, 300 questions, and in Erodo we are already having much number of questions. So this is a long program, a 1 year program, let's say. So do subscribe, and this will be really helpful for you, for all those students who want to secure good rank. Okay, students. Okay, happy learning.